This is our first example of a proof. We will assume that n is an integer, and we will show that if n is even, then the expression n squared plus 3n minus 5 represents an odd integer. What is it that we're actually trying to show? Let's break it up. We say that if n is even, then n squared plus 3n minus 5 is odd. This is an example of an if-then statement. If this condition is satisfied, then this condition will be satisfied as well. We can use a shorthand to write the same statement. N is even implies that n squared plus 3n minus 5 is odd. This part of the if-then statement is called a hypothesis. This is what we're assuming to be true as we're going through our proof. This part of the statement is called the conclusion. So what do we have to do to prove that this statement is true? We'll assume this and show that this follows from our original assumption. This is called a direct proof. It may be a little counterintuitive to look at the conclusion first, because we've always been told, read the problem, look at what's given, and then solve the problem. Well, if you think about real life, it actually kind of makes sense to look at where you want to go and then see what you can do to get there. And the same with mathematical problems, and the same with proofs. Yes, we will assume that this is true, but this is of no use to us at all unless we know where we're going with this. So we will typically start by looking at the conclusion. We cannot assume the conclusion, but what we have to do is ask ourselves, what does it take to show that this is odd? So here is our question. What does it take to show that n squared plus 3n minus 5 is odd? Because assuming that the statement is true, whatever it takes is what we're going to do. So we need to know what it takes. Well, remember when we talked about even and odd numbers, we learned that all even numbers can be expressed in the form 2 times an integer. And odd numbers are the ones that can be expressed as twice an integer plus 1. So in order to show that this is an odd integer, we'll have to express it in the form 2 times an integer plus 1. We need to express n squared plus 3n minus 5 in the form 2 times some integer plus 1. Now that we know what it takes to show that this is odd, we go back and look at what we have. What we have is that n itself is even. What does that tell us about n? It tells us that we can write n as 2 times some integer. So now we look at what's given. What is given? And what's given is that we can write n as twice some integer. So when we write up the actual proof, we will start by saying we know that n is equal to 2k for some k, and now we'll try to express this in this form. That's what our proof is going to look like. Now let's do the proof.